You wake in the dark, and the room feels slightly off. Your alarm still reads the right hour. Your phone glows the same numbers. But the compass app you opened on a joke to check direction spins like a slot machine. North is where it always was yesterday, and now it isn't. You tell yourself it's a glitch. Technology glitches. Phones die. Maps recenter. So you shrug it off, make coffee, and step outside. The morning smells like every morning. Wet asphalt, distant diesel, a neighbor mowing. But the birds are quiet. The sky is the same blue. The trees don't look different, except somewhere. It's a tiny, impossible wobble in how you feel the world under your feet. That wobble is the first whisper. It will feel like nothing to most people. A quirk of an app. A flight of fancy. Yet for those who know to pay attention, the geologists, the sailors, the old-timers who still read maps by hand, it is a line being redrawn under the skin of the earth. The magnetic pole drifts. It has always drifted. Like a slow, lazy wanderer, the magnetic north pulls and pushes over centuries, wandering through Canada, across islands, over oceans. Scientists chart it with patience. Compasses twitch. Maps get updated. It's as natural as tides. But sometimes the wanderer speeds up. Sometimes the needle lurches faster than anyone expects. And once in a very long while, the poles do more than wander. They flip. You don't need to understand the physics to feel the story. Deep below the crust, molten iron churns in a vast, blind ocean. That ocean has moods. It makes magnetic fields. Those fields wrap the planet in an invisible shield that keeps lethal particles from the sun at bay, that gives your compass its steady finger. When that churning changes, the shield changes. When the shield falters, life on the surface doesn't stop, but it does notice. Satellites misbehave. Atmospheric chemistry shifts. Migrating animals lose their bearings. The sky doesn't collapse. Things start behaving in ways you might only read about in old journal entries and apocalyptic tales. Right now, the pole's wander is more than a curiosity. The needle, the old brass arrow in a wooden box that once guided sailors, is accelerating. It's moving faster than in living memory. Maps need reprinting. Airlines reroute. Mineral explorers update compasses. Comments bump up funding for observatories. That's how the idea first reaches you. A news alert about increased polar motion. A tweet links to a satellite graphic. An opinion piece whispers that we live in a time when the Earth is restless. If the pole keeps moving, deep questions bloom. How close is a full reversal? What does reverse even mean for you? Sipping coffee in your kitchen? Will birds crash into skyscrapers? Will GPS be lost? Will the aurora swallow the southern states? The headlines play both fear and comfort. Scientists not to worry and will in smaller print, but plan infrastructure resiliency. You decide to read further. You find descriptions of past reversals when magnetism simply turned inside out and then back again. The geological record records teeth marks of those flips in ancient rock and ocean sediment. Magnetic fields weak, then rebuild in the opposite direction. Life survives. The planet doesn't pause. But those hints in stone are not comfort food. They are cold, patient notes from a timescale that dwarfs human memory. They say, "This has happened before," slowly, and life continued. But they do not say it was easy for the creatures who lived through the change. Your first practical worry is navigation. GPS seems bulletproof until the first storm knocks out a few satellites. The systems are redundant until the radiation belts swell when the magnetic shield wobbles. Power grids, those elegant webs that carry life across continents, are designed with tolerances, but not for systemic space weather punching at the magnetosphere. Transformers are delicate. A solar storm, when the planet's magnetic armor is warped, becomes a hammer. The last time something like that happened and the grid experienced a real scare, the Carrington event of the 19th century, telegraph operators were left sending sparks. Imagine that, on an exponential scale, shipping containers misrouted, air travel halted, satellites fried, the convenience economy paused. But before you picture blackouts, let the story get human. On the morning, the government quietly first discussed contingency measures. You read emails from a childhood friend who is a marine biologist. She describes whales arriving off the coast in places they don't belong, their sonar useless where it once sang. A neighbor posts a shaky video of birds circling a stadium at dawn, disoriented, refusing to land. Your inbox fills with anecdotes. A local farmer calls his brother in the next county and describes compass needles pointing in different directions at each end of his fields. These are small, terrifying details that make the abstract pulse of paleomagnetism feel immediate and messy. Then the satellites begin to complain. A weather satellite misses a calibration. A GPS offset appears. Headline numbers are still cautious, minor service disruptions, but the chatter among technicians is faster, spooked. They talk about increased particle flux and about how the near-Earth environment is changing in ways ordinary software was NT designed to handle. They speak in Python scripts and telemetry logs, while the rest of us see rerouted flights and a map on the news showing tiny red dots where GPS lost accuracy. Cargo flights over polar routes reroute south, costing airlines millions. Shipping lanes shift. The global economy hiccups. You notice that military planners are less reassuring. They begin exercises. They test ships and planes on backup guidance systems. They brief leaders on worst-case scenarios, prolonged loss of satellite navigation, temporary collapse of some communications, increased radiation exposure for crew at high altitudes. They ask the public to remain calm. They also tell private companies to test their humidity reduction systems and to mentally prepare for supply chain jitter. Calm in public, frantic in private. The pattern is familiar from every crisis humans have rehearsed. And then the geophysicists give you a new word: excursion. It's a partial flip, not the full inversion painted by disaster movies, but the field buckles, weakens, and wanders splendidly before returning. Scientists stress excursions are far more likely than full reversals in any given century. But excursions matter. When the field dims, the magnetosphere's defense is thin. Solar storms, once whispering concerns, now become loud threats. The phone on your counter dings again. The NOAA app warns of elevated geomagnetic activity. Your neighbor mentions losing contact with their drone mid-flight. A fisherman reports his compass acting like it has a mind of its own, swinging like a drunk. You begin to imagine scenarios in everyday life. The bus driver who has always relied on a digital route map now needs to know old-fashioned paper routes. Farmers who use GPS-guided tractors face a sudden choice between expensive recalibration and getting stuck in a wet field. The amateur pilot who takes a short hop to visit family now files a different plan because polar routing for cross-country flight is suddenly unreliable. Emergency services test analog beacons. Cities dust off old plans, the paper ones with phone trees and hand-delivered notes, as if for the first time communities might need to speak without the web. But the deeper story is not only inconvenience. The magnetic field interacts with the atmosphere and with living organisms in subtle ways we barely understand. Migratory animals, birds, butterflies, even plankton use geomagnetic cues to find home. If those cues blur, migration routes could become garbled for a season, then a decade. Fisheries might relocate. Ecosystems could shuffle as species search for environmental conditions their ancestors never experienced. The result is not a collapse overnight, but a slow, lurching reweaving of nature's map. One that will touch your dinner, your weekend plans, your childhood shoreline. Yet through all this, you notice something. When people meet a new kind of trouble, they do two things consistently. They grieve for what is lost, and they tinker. Within weeks of the first major excursion alerts, tech startups offer new GPS redundancy devices. Mechanics produce hardened transformers, amateur radio groups set up emergency networks, and universities expand research into magnetoreception in animals. The supply chain stumbles, but does not snap. Practicality appears like a stubborn muscle. American communities test analog resilience. Farmers relearn compass use. Pilots practice non-GPS navigation. The panic is tempered by action. Late at night, when the news cycles slow and screens dim, you think about the big questions again. Would a full pole reversal make civilization crumble? Geological record says no. Life persists. But the human systems, so much of modern life depends on satellites, grids, radio-dependent logistics. Those are young and brittle. A long excursion could expose vulnerabilities so fundamental that you detaste them in your daily life. Delayed medicine shipments, interrupted services. A week where your morning coffee is harder to buy than it used to be. And then, as if to remind you that the Earth keeps shifting not just at its core, but at surface politics, to a quiet report appears. A consortium of scientists has identified that the magnetic north has been moving significantly faster over the last few decades than it did in the 19th century. They publish maps and color gradients. The needle's speed becomes a news graphic. It's not an apocalypse, it's a pattern. But to someone who's been watching the birds, the compasses, the satellites, it feels like a countdown. You sleep that night feeling both small and strangely alert. The magnetosphere, once an invisible shield you never considered, has moved from the domain of deep geophysics into your kitchen and your commute. Tomorrow, you'll open the paper and read the same phrases. pole migration, geomagnetic excursion, satellite anomalies. But tonight, the words are stories tucked into your bones. And when you wake again, the compass on your old brass keychain, the one your grandfather used to carry, sits on the table. Its needle, slightly tarnished, still points somewhere. You pick it up, and for a moment, the steady arrow steadies you. Then it twitches. Outside, the sky is calm. The birds are back, or they were at least quiet this morning. But somewhere, deep under the world, the wanderer is moving. The needle will tell the next story. The next morning, the headlines change. What started as a curiosity is now an agenda item for city planners and airline operations. And at the bottom of page 3, buried among other worries, is a short government notice. Contingency grants for geomagnetic resiliency. Funding to retrofit critical transformers, and specific guidance to keep aircraft and satellites safe during intense geomagnetic storms. The tone is bureaucratic, but the message is clear. Prepare. You have questions now that are larger than maps. You want to know, how bad could it get? How fast could a change happen? Who is watching the watchtowers at the core of the Earth? What do we do if the shield thins and the sun storms find weaknesses? You make a small, practical list. Locate the old NOAA radio frequency. Buy a small emergency battery. Find where your city stores extra water. It feels humble and insufficient, but it is a start. Then, before the sun sets on this day of small preparations, a new alert appears. A cluster of correlated anomalies and satellites, a handful of unexplained compass deviations across the Arctic, and a piece. And a surprisingly candid quote from a geomagnetics researcher that makes the newsreaders sit up straight. He says quietly, and with a tone that cuts through the usual PR calm, "We are in an unusual period. Excursions happen. Full reversals are rare on human timescales, but the field is weaker in places than it has been in thousands of years. That means the consequences of big solar storms or prolonged excursions are amplified." You look at that sentence until it blurs. For the first time in days, the abstraction feels personal. Not because the Earth will end, but because life's scaffolding satellites, grids, migratory patterns, supply chains is more delicate than you assumed. And then late that night, you hear the distant radio. Scientists describing a pattern so precise it chills you the magnetic north. S migration appears to be linked to deep fluid flows that can reconfigure on a human timescale. The scientist's voice is measured, but the words do the work of moth wings in the dark, shifting core currents. Weaker field strength, potential excursions. You fall asleep with the compass heavy in your hand, the needle finally calm, and in the morning, ULLB ready to hear part 2. But tonight, the thought tucks under your skin like a small animal, restless, alive, moving. The magnetosphere is changing. The needle will tell the next story. And the strange thing is, most people wouldn't even realize anything was happening at first. Life in America would look the same on the surface. Kids going to school, commuters stuck in traffic, planes landing at busy airports. But beneath that everyday normalcy, the machinery that keeps the modern world running would begin to feel slightly off, almost like reality had a small glitch no one could quite explain. It would start with the instruments. Machines notice before humans do. In geophysical labs across the country, researchers would look at their monitors with furrowed brows, seeing numbers drift in ways they shouldn't. Magnetometers in Alaska would begin reporting fluctuations outside expected ranges. University labs in Colorado would run calibration tests again and again, thinking something was wrong with their equipment. Aviation engineers would quietly exchange emails, asking if anyone else had noticed compasses slowly losing their accuracy on certain routes. And slowly, reluctantly, a hush would spread in scientific circles, the kind of hush that comes when specialists realize they may be witnessing something historic and possibly dangerous. Before long, strange reports would begin trickling in from pilots. Veteran airline captains flying over the Midwest would call in saying their onboard compass was pointing 2 or 3 degrees off its usual direction. Tiny shifts at first, barely noticeable, but consistent and growing. Flight dispatchers in Chicago would write it off as minor atmospheric interference, but the pilots would swear something felt wrong. A few weeks later, those same pilots would report the same compasses deviating by 5 or 6 degrees, forcing them to rely more heavily on GPS and visual corrections. Meanwhile, small private aircraft, especially older models, still reliant on magnetic navigation, would quietly start showing up in FAA incident logs with unexplained directional errors. At first, it would all be dismissed as harmless anomalies. But then GPS signals would begin behaving in ways that were harder to ignore. GPS satellites orbit nearly 12,000 miles above Earth, and their systems rely on extremely precise timing and stable electromagnetic conditions. As Earth's magnetic field weakens and becomes more chaotic, atmospheric layers like the ionosphere start warping those signals, bending them, scattering them. And so a delivery driver in Kansas might suddenly see his navigation app spin in circles. A farmer in Nebraska using GPS-guided tractors might watch his equipment drift off a straight path. A cargo ship approaching the West Coast might notice its position lag by 10 or 15 seconds, long enough to matter. To the average American, these glitches would feel like nothing more than annoying technical problems, the kind you shrug off, restart your phone, and forget about. But to scientists watching closely, these weren't mere errors. They were early symptoms of a world beginning to shed its magnetic skin. Then, the skies would begin to change. At first, it would be subtle, soft arcs of pale green light somewhere over Montana. Faint ribbons of purple shimmering over Oregon. A glow on the horizon in Minnesota, even when the forecast said clear skies. People would take videos and post them online, calling them weird northern lights or NW World vibes, assuming it was just some rare atmospheric event. But it wouldn't stop. The lights would keep returning, brighter, more vivid, spreading farther south than they ever should. Within weeks, auroras would appear over New York, St. Louis, Denver, even northern Texas, the kind of displays that historically required massive solar storms. Except this time, the sun would be quiet. No major solar flare, no coronal mass ejection. And yet the sky would look like a neon sea. That's when scientists would truly begin to worry. Auroras without solar storms means only one thing: the magnetic field isn't protecting us the way it used to. It's thinning, twisting, tearing at the edges, a shield turning into a sieve. And if it continues weakening, the consequences could cascade quickly. Airports across America would be the first major systems forced to adapt. Compass-based runway designations used by every pilot during takeoff and landing would suddenly become inaccurate. Runway 18 might no longer point to 180 degrees south, meaning signage and charts would need urgent updating. Air traffic control centers would reissue guidance documentation. And pilots flying older or military aircraft, depending heavily on magnetic readings, would require new correction procedures. Meanwhile, power companies would begin noticing irregularities too. The electrical grid is deeply sensitive to geomagnetic currents. As the magnetic field distorts, more charged particles penetrate the atmosphere, leaking into long metal structures like transmission lines. Operators of the U.S. grid, especially in the Midwest and Northeast, would start recording small spikes, unexplained surges, and unusual heating in transformers. Nothing catastrophic yet, but enough to raise eyebrows and prompt emergency evaluations. And then the animals would begin to act strangely. Migratory birds flying across the Great Plains would veer off their regular routes, creating sudden mass gatherings in places they're not supposed to be. Whales along both coasts would beach more frequently. Sea turtles in Florida would crawl ashore at the wrong locations. Beekeepers in the South would find colonies disoriented, unable to navigate even short distances. And pet owners might notice dogs behaving oddly on walks, pausing in the street and circling with confused instincts, sensing something humans cannot. All of these clues would paint a single alarming picture. The Earth's magnetic field is becoming unstable, and it's beginning to affect everything. Federal agencies like NOAA and NASA would issue quiet internal alerts first. Nothing alarming to the public. Cautious memos acknowledging increasing magnetic volatility. Behind closed doors, emergency meetings would be held to discuss worst-case scenarios. They would model the effects of a full magnetic excursion on aviation, power grids, satellites, and communication networks. They would draft early-stage plans for how to protect astronauts aboard the ISS, how to safeguard critical infrastructure, and how to create public guidelines if things worsen. But eventually, the situation would become impossible to ignore. Not when auroras are glowing over the skyline of Dallas. Not when GPS outages begin hitting entire regions for minutes at a time. Not when dozens of satellites suddenly require altitude and orientation corrections. Not when pilots begin reporting compasses swinging by 20 or 30 degrees mid-flight. And so, slowly, uneasily, the public would start to realize that something extraordinary is happening. Something earth-changing. Something humanity has never experienced in written history. Yet, this is only the beginning. If you want, I'll continue with part 3, where the real consequences begin. Not just glitches, not just lights in the sky, but the moment America truly feels the magnetic shift touching daily life. By the time the auroras start dancing over cities like Atlanta and Phoenix, even people who never cared about science begin to feel it, That strange, unsettling sense that the world is shifting in a way no one alive has ever witnessed. News anchors try to stay calm, calling it unusual atmospheric activity. But even they can hide the nervous tone creeping into their voices every time a pilot reports a compass deviation or a farmer claims his GPS-driven tractor plowed a crooked line despite perfect calibration. And then one night, everything changes. It begins as a string of quiet digital failures. Nothing dramatic. Nothing you'd notice unless you happen to be awake at 3 a.m. Eastern Time. A weather satellite over the Pacific suddenly loses communication for 12 full seconds. Another monitoring satellite in polar orbit misreads its orientation and triggers an automated safe mode reset. The Space Weather Prediction Center notices both events but initially assumes it's a coincidence. But it isn't. Within minutes, ground engineers across NASA, SpaceX, NOAA, and the Department of Defense begin reporting issues. Satellites drifting off course, instruments glitching, unexpected resets. At first, it looks like some massive cyberattack. But then, someone checks the solar activity readings, and the sun is quiet. No flares, no storms. The problem isn't coming from above. It's coming from Earth itself. For the first time in modern history, a magnetic excursion, the early phase of a pole reversal, is strong enough to scramble satellites in real time. That's when the public first feels it. Phones across parts of the country lose location tracking for several minutes. Navigation apps freeze. Airline flights preparing for takeoff in Chicago, Denver, and Houston are temporarily grounded because magnetic heading indicators show sudden 5-degree jumps. Emergency dispatch centers receive calls from confused drivers whose dashboards display errors they've never seen before. And while all of that is happening, the sky turns the color of electric emerald. Not just for a minute, not just for an hour. The aurora spread across the entire United States, from Seattle to Miami, glowing so bright that city streetlights cast double shadows. One from the lamps and one from the dancing waves in the heavens. It's beautiful, terrifying, hypnotic, like the sky itself is rippling. Millions step outside to watch. Millions take videos. Millions think it's the most stunning thing they've ever seen. But scientists, they know exactly what this means. The magnetic field, Earth's invisible shield, is weakening faster than anyone predicted. In some regions, it's already dropped by nearly 30 to 40%. That's not catastrophic yet, but it's the kind of drop you expect over centuries, not months. And the weaker the field becomes, the more charged particles slam into Earth, interfering with satellites, electronics, and power grids. America is now feeling the early stages of what a magnetic pole reversal looks like. The first major nationwide disruption arrives a few days later. It happens during a calm, sunny afternoon, the kind of day where no one expects anything unusual. In the Midwest, hundreds of large power transformers experience sudden geomagnetically induced currents. Not enough to melt them, but enough to heat them and trigger emergency shutoffs. The grid automatically reroutes power to prevent damage, but the sudden strain causes rolling brownouts across several states. Cities like St. Louis, Indianapolis, and Omaha experience flickering lights. Some neighborhood substations trip offline entirely. Internet speeds drop. ATMs temporarily fail. Traffic signals switch to blinking mode. And in that moment, that exact moment, America realizes this isn't just a cosmic light show. It's a real physical force pressing on the infrastructure of a modern civilization. But the most unsettling part: certain places begin to experience magnetic anomalies strong enough to mess with the human sense of direction. Studies have shown that humans do have a weak magnetic sense, far less accurate than birds or whales, but still present. So when the fluctuations intensify, some people start reporting dizziness, difficulty telling east from west at night, or the sensation of being slightly pulled when standing in open areas. Hospitals begin noticing a spike in these symptoms. Nothing deadly, nothing dramatic, just odd. Like something deep in the human brain is confused. Meanwhile, animals across North America behave like they're living in another reality entirely. Migratory birds scatter off course by hundreds of miles, filling skies in places they don't usually fly over. Fish migrate irregularly. Whales beach in record numbers along the Pacific coast. Even cattle on rural farms show strange, restless movement patterns. Dogs act agitated. Cats stare at walls as if sensing something invisible. The world is losing its compass. Government agencies finally hold a joint press conference. NOAA, NASA, and the U.S. Geological Survey. They don't use words like pole reversal because they know how terrifying that sounds. Instead, they call it a period of magnetic instability. They reassure the public that there's no immediate threat. They emphasize that the process could take centuries, or it could stop entirely. But the truth behind the scenes is far less comforting. Internal reports warn that Earth's magnetic poles are moving up to 35 miles per year, faster than any time in recorded history. Regional areas of magnetic collapse are forming in the South Atlantic and rapidly expanding. The U.S. grid is not designed for sustained geomagnetic stress. Satellites may need constant recalibration to stay operational. GPS may become unreliable at random times for unpredictable durations. And all of this is happening without a major solar storm. If the sun releases even a moderate flare during this weakened state, the consequences could be enormous. The U.S. government begins preparing quietly. Emergency backup grids are tested overnight. Military bases switch to hardened communication modes. Airlines rewrite navigation procedures. Satellite companies upload emergency firmware designed for rapid magnetic drift. Submarines adjust internal guidance systems. And in homes across America, people lie awake at night, seeing videos of glowing skies and hearing rumors on social media. Is the North Pole moving? Is this dangerous? Could this be the beginning of a reversal? What happens if the magnetic field collapses? The truth, though rarely spoken aloud, is simple. The magnetic field is changing right now, and no one knows exactly how far it will go.